Hello everyone and welcome back to another tutorial. In this video, we are going to write a Linux driver and then populate the driver into the kernel image using the Yocto project. And then finally, same as before, we will test the driver in the IMX233 board. So let's get started. So we have to create a new folder. We are going to create a new driver, make it test driver. So in the next step, you need a text editor or any IDE to write the C programming because the driver will be written in the C program. So I use Visual Studio. And if it is the first time you are using the Visual Studio, make sure that you have installed the extension on the Visual Studio. For this purpose, you have to go to the extension on the left-hand side and install the C++ extension. It takes a while to load everything. Okay. Yeah, from here you have to install it, but I already installed this extension. So I will open up my folder under the desktop, test driver. And then I have to create from this plus button, I have to create a file. For example, Shaheen driver.c. And here, if you're familiar with the C programming, you have to include some libraries. I will include, because I'm going to write a module, I have to include the Linux /module.h. And because we are writing a driver, we have to specify the input functions. I mean, initialization function and exit function. I mean, in the C programming, in the normal C++ programming, the main function is the first function that will be executed. But because it is a driver, is a little bit different, we have to specify the init function and exit function. To do that, we will write module underline init. So this function is coming from this library, and then we have to specify our function. For example, my driver underline init. For the output one, module underline exit. My own function, driver underline exit. So in that case, when we insert the module, the kernel will load this function, and when we remove the module, the kernel will execute this function. So we have to define these two functions. We use a static. The init function has an integer output, and then we have to use this syntax, underline init, and then the driver name, my driver underline init, no input, void. And so return 0, which means that it's okay, everything looks good. And the exit function doesn't have any output, a static void. This syntax, underline exit, and then my driver exit function, same as before, no input. And here we have to write the exit function. So we can print some message when the driver is initialized. We can use print k and our message. So in a normal C++ programming, we use print S, or printf, but those are when we are using in the user space. But we have to use K because we are in the kernel space, and the message will be shown on the kernel message. I show up a simple message, driver init, next line. And on the exit, I can do the same, print K, driver exit, /n to go to the next line. And we have to add one more line because we are using, this driver will be inserted to the kernel. So the kernel should understand, it is it has a license or not. So we have to add module underline license. You can add any license that you would prefer. For example, MIT, GPL, GPL, V2. We can add more description here. For example, a module author. So in that case, when the kernel is when somebody asks kernel, what is the author of this driver, it will just show up this text here. For example, I can write my name. We can add description to the driver, module underline description. You can give a short description about your module. This is a test driver. You can also say module underline version. So you can specify the version 1, for example, and you have to compile these codes. In order to compile this code, you need a make file. I create a make file here. Go to the make file. At the first one, you have to say obj-m. You can say the driver file, Shahim underline driver dot object dot o. And then you have to specify all, which means that when somebody calls this make file, you have to run this code. Make is a software. We are using a variable to specify that. Anything which is started with the $sign, and in the parentheses we have a variable. So this make, we have to specify it here, but in our case, Linux already know what is this variable means. Make is a software which is the make, and then we have to say -c, where this should be built under the lib, under the modules, and we can use shell script here, shell uname-r, and build directory, and where are the module is located. Same as before, we can use the shell command, and here pwd, and compile it as a modules. That's everything. Save this file. Make sure everything looks good. You can open up a new terminal. cd to the, where the file is located. So it's here, and then make it. So make is the software that help us to compile the file. It basically reads these make files and then execute these lines. I can go back there and hit the enter. Okay, create the object file. And it also create the .ko kernel object. So this is the file that, it is our basic, it is our main driver, and we have to insert this file into the kernel. Before that, I can show you the ls mode command. There's a command named ls mode, means that list modules. I hit the enter, it will show us all modules. For example, here, it shows all the modules here. Some of them are 0, which means that this module is not used at this time. And then I have, in order to insert the module into the kernel, I have to say sudo ins mode, and then the kernel object file. Ins mode means that insert the module, and this is our module or driver. Hit the enter. Make sure you have a super privilege. Hit the enter. No error, and it should be inserted into the driver. I can use the ls mode command once more. List modules. Go to the top. Yes, my driver is inserted, but it is not used because it actually just have to print something on the kernel message. I can open up a new terminal. There is a command dmessage, and it will show us the kernel message. Woohoo! Our driver is initialized. So when we use sudo ins module, so this driver is inserted to the kernel. And as I said before, the kernel look at this module init, and when it's inserted, it execute this function, my driver underline init. So when we inserted, this module is run, and it will print the init driver onto the kernel message. I can use a same command dmessage, and I can give a command dmessage. -wh. So in that case, we can see the kernel message on a real time. If I make it smaller, so as soon as I remove this kernel, this driver, I can use sudo rm mode and then the kernel name, the driver name. RM mode means that remove module. I hit the enter, and immediately after that, on the kernel message, I will see that the driver is exited. So in that case, so the kernel will understand that somebody removed this driver. So according this line, module exit, it will execute my driver exit. And inside this my driver, it's just print us this message. So right now we have a very simple driver. We inserted the module manually and removed the module manually. But in the real case scenario, when we have a very complex and more dedicated driver, so we just put this driver into the kernel, and then kernel automatically will understand that when it should be run these, when should run this driver. So in that case, say we wrote a driver for the plugging USB device. So when we insert the USB driver into our system, it automatically, I mean, the kernel automatically insert this module. So when we plug the USB device, the kernel will run this command. So we will see that this command will pop up, and it will, assign this driver to the USB device and do the task. So right now we will be able to write a kernel driver, but how we can integrate this driver into our Yocto image. So let's see how we can do that. Control C, we don't need it anymore. To do that, we go to the Pocky project. We have to add a recipe into our system and say to the bitbake, run this recipe and then install our driver and then integrate it and populate it into the image kernel. So when we go to the Pocky folder, we have a meta skeleton. So this is a meta layer that Yocto just provided for us to give some view about the writing different recipes. We can go to the recipe kernel. Hello mode means that this is just template for writing a module for writing a recipe module for the Yocto project. We will go to this one. We have a recipe in here. Let's copy up both of them. So at this point, you can create a new layer, or you can just easily select one of these meta layers and inject your recipe into one of them. Right now, we make a very easy way. Just use one of these layers and write our own recipe into one of them. But later on, we will show you how you can create a new layer. For example, I can go to this meta layer, meta FreeScale third party, for example. I can select any of them, say connectivity. I can create it here. So on here, you can create a folder to specify the name. I can say easily Shaheen. Folder. It is, you can write whatever you want and paste the folders here. Go to the files, just remove these files. Change this recipe to the desired name. So my desired name is just simply Shaheen. And after the underline, you have to specify the version. So in that case, a Yocto project will understand that which version of these recipes are available and always use the latest version. And you can use this version later on in the recipe as well. Rename it. So right now, the recipe name is Shaheen and the version is 0.1. You can make a summary, say this is a hello world recipes. So the license is a GPL v2, or you can just remove these two lines, make it very easy, and GPL2 close. No need for this copy as well. remove the copy. You can add your own driver here under the test driver. We already tested this file, so it should be good to go. That C file and make file. Let's copy them in here. And you have to specify the output file here. To me, it's the Shahim_driver. So basically, it should be .ko kernel object, but in this case, we have to remove the ko. The file is src_uri. Here it mentioned that go to the files, and these are our resources. We have a make file, and we have another .c file, which is Shahim_driver. Yeah, looks good. And let's open up our make file. So right now, we use make software, and we specify that you have to build it for our host machine at this address. But the thing is that using the Yocto, we are not going to compile the driver for our own host system. Instead, we are going to compile this driver for our target board, which is the IMX board. So this part should be changed as well. Let me go back to the skeleton. I just go to the Paki folder, meta skeleton, go to the kernel, hello mode, files, and the make files. So let's see what we have in here. So it's good, same as for us. It uses a variable for the modules, same as for us. We just put this variable directly in here. But here for -c, it uses a specific variable, kernel source, but we didn't specify it here. Let's use this variable in our code as well. So I remove this part, say kernel source, back to the make file. So it has the all. Let's copy these two lines, go back here and do the same. I can copy the source as well. Everything should be good. But this time we are going to module install, which means that install module, compile the module and install them as well. I just saved this one. Everything looks good. And the recipe file is good. I can go to the bitbag. So I will go to the Paki and open up a new terminal. Same as before, we have to initialize our environment. So first, instead of saying bitbake, instead of saying core image minimal or core image base, let's just compile this recipe. The recipe name is Shahim. So I just say bitbake Shahim, hit the enter. So right now, bitbake is going to parse all available recipes and looking for this special recipe, Shahim. as I mentioned earlier, we have a recipe name and then underline recipe version. So in here, we have to just specify the recipe name. Let's see what we got here. At this point, we are not actually creating a new image. Instead, we are just compiling this recipe and see if it is working or not. I mean, if you have a very big project, if you use just say core image base, it will compile everything and you might get lots of error. And I mean, it's really hard to track the error in here. So because this time I just use, and create a new recipe, I can just compile that specific recipe and see if it is working very well or not. And if that was good, after that, I can compile the whole image. Okay, as you can see, it finds our recipe, but it's failed. Okay. Checksum file error. So there's something wrong with my license file. Let's check it out. Okay. I have to say closed. Okay. And then feedback again. So as you can see, that was so easy for me. I just use only one recipe, so I can easily track that. It find my recipe, do compile. It is just compiling it. Install the recipe. Okay, everything good, looks good. So I can use bitbake core-image-base. So this time I will populate this recipe into the kernel image. Okay, it's done. I will go to the Pocky. I will go to the build, temp, deploy, images, and my machine. Yes, this file is just modified and created. So the next step, I have to write the image into my SD card. Virtual machine. Let's open up a terminal from here. Open in terminal. So if you remember in the last video, in order to, because it is a compressed file, the .gz, we open this file and then extract it. But let's make something easy in here. We have a command, gunzip -c, and we have to specify the file, core image base .vic file .gz, and then or sudo. The dd command was used to burn the file into the SD card. So right now, this is our input file. So using the gunzip, we extract it, and then using the dd, we have to use, burn it into the SD card output file, which is the dev sdb. Hit enter. The password, and it should be good to go. So it's ready. I can go to the root file. And then, so we had to find the kernel object somewhere in the root file system. So I burned the SD card, and inside the root file, I have to find the kernel object because it is the driver that we just wrote. So, but when we go here, we cannot find anything here. It should be shame_driver.ko, but nothing. So let's see what is going wrong in here. On the Pocky, open up the Pocky under the build, under the conf and local conf. Right now, we said that, I mean, we wrote a new recipe, but we didn't actually use the recipe. We have to somehow tell the bitbake and, I mean, read the new recipe and compile it for us. To do that, we have to go to the local conf file, and somewhere in here, we have to write down image underline install underline append plus equal to, and the recipe name. So my recipe name was Shahim. Make sure that you are using plus equal, because so bitbake and Yocto project, looking at this variable image install append, and during the installing, they will read these recipes and append to their image, I mean the generated image. I will save this file and go to the bitbake and run the core image base once more. Okay, it's done. Let's see what's happened. Under the Pocky, build, temp, deploy images, this one. Yeah, it is just updated. So I will go back and burn the same file into the SD card. I can add BS flag as well, 1 meg, and then I flag equal to full block, or flag is equal to direct conv equal to fsync. Status is equal to progress. Hit enter. So right now I can see the progress here as well. Okay, go to the root partition, and same as before, search for .ko file. Woohoo! We have our driver here. So probably should be good for running on the IM export. I will insert the SD card into the IM export, plug in it using the USB into the computer. I'm going to use it on my host PC. I need a software. I need a PuTTY software. Go to the serial, COM3, and the speed is 11.5200. And finally, I have to power up the system. Open. Looking good. So in here we have the kernel message. So if the driver is pop up, we have to see it here, but it didn't. Let's log in. I can use ls mode here as well, but as you can see, no module is inserted. The reason is that the kernel is looking for any devices that needs this driver and then insert this module. But in our case, the driver is just showing up some message. So no driver is, no device is looking for it. So the kernel said there's no need to insert it at this time. So it doesn't insert the kernel. But as we have seen earlier, the driver is in the image, but it didn't insert it. So what we can do, let's power off this board. So what we can do, we can ask Yocto to put some variable into the kernel and ask kernel to automatically run our own driver. To do that, we have to go to the localconf and add this line, kernel underline module underline auto load, and then we have to specify the driver name, Shaheen underline driver. So don't mess up these two. Image underline install append, we have to specify the recipe. Kernel module underline autoload, we have to specify the driver name. Save this file and we can rebuild the image. Okay, it's done. I will insert the SD card on virtual machine. And same as before, I can go to the desktop, Pocky, or using this terminal, I can repeat the process. Okay, it's good. Let's unmount. And I have to add the SD card into my IMX board. Host machine. Same as before, I need the PuTTY, serial, COM3, 11.5200, open up. Finally, I have to power on the device. Looks good. The kernel is starting. Okay, it's here. As you can see here at this line, the driver is automatically inserted, and this is the output of our print K functions. So I can actually log into that. I can use ls mode. Woohoo, our driver is here. So yes, we learned how to write a simple driver, how to compile it, and how to insert it and integrate it into our Linux kernel image using the Yocto project. At the end, let me show you how you can create a meta layer. Open up a new terminal. And say source environment. You have to use bitbake dash layers, create layer. Before that, you have to, right now you are in the build directory. It's good to make all the meta layers at the same place. So go back to the Pocky folder and say bitbake dash layers, create dash layer, your layer name, I call it meta Shahim, and then hit enter. Okay, as you can see, the meta layer, the new meta layer is created. We have a licensing file, we have a conf file under the conf. So in here said that go to the current layer directory and recipe something, and under that go for looking for the recipe file. I have to use the same style. You have to create a new folder. Recipes dash driver, for example. And inside that, we have to, based on this example, we have to have another folder. I can copy and paste everything from my previous location to here. Under the driver and here. So right now, in the next step, I have to add this file, the address of this file, into the build conf bb layers. I have to add it at the end of this line, but let's ask bitbake to do that for us. I can use bitbake dash layers, add layer, and then my meta layer, hit enter. Okay, I have to go to the build directory and hit enter. Or, okay. I have to set in the previous directory, there is a meta layer with this name. So add that one to the BB layer. Okay, hopefully it's done. Under the BB layers, I can see the last meta layer is added. And You can use the bitbag to run your new layer. So the bitbag goes through all layers and then search for your recipe and install the correct recipe for you. Thank you for watching.